However, many rational numbers are not the result of cubing a number. So not all rational numbers are perfect cubes. So given a rational number, how can we determine if it is a perfect cube? Like we learned with perfect squares, for a rational number to be a perfect cube, its numerator and denominator must be perfect cubes. So here's an example. We have the cube root of 8 over 27. So we can split that up into the cube root of 8 over the cube root of 27, which is equal to 2 over 3. This example shows how to find the cube root of a fraction. And it shows that 8 over 27 is a perfect cube with 2/3 or 2 over 3 as its cube root. This is an example of a perfect cube that is not a whole number. So note that for this fraction to be a perfect cube, both its numerator and denominator needed to be perfect cubes. We had to be able to take the cube root of 8 and the cube root of 27. It wouldn't have worked if it was the cube root of 26 or the cube root of 28 or the cube root of 7 or the cube root of 10 in the numerator. It had to be perfect cubes in the numerator and denominator in order for us to do and complete this example. Any rational number consisting of a perfect cube in the numerator and denominator is itself a perfect cube. That provides an infinite number of perfect cubes between any two numbers, for instance, between just 0 and 1. And then you just put 1 in the numerator and keep putting the next highest whole number perfect cube in the denominator, since 1 is a perfect cube itself. Since the whole number perfect cubes extend to infinity, so too do the number of rational perfect cubes between 0 and 1, or between any two whole number perfect cubes. So here we can see this example. Here's what we're talking about. Here is the series of rational perfect squares with 1 in the numerator. So see, we have the cube root is 1 over 1. The number is 1 over 1. The cube root of 1/8 is 1/2. Of 1/27 is 1/3. Of 1/64 is 1/4, and so on and so forth. While we stop at 1/1000th, there is no limit to how small these can become. And there's nothing unique about having 1 in the numerator. We really could use any perfect cube in the numerator. So you could have 8 in the numerator or 64 in the numerator and combine it with any other cube root in the denominator, and that fraction would still be a cube root.